Okay, so if you've been feeling a little disoriented lately by the sheer breakneck speed of AI development, well, you are definitely not alone. Today, we're diving into an absolutely massive paradigm shift in the software world. We are breaking down the foundational first chapter of Chip Huon's fantastic book, AI Engineering. In this explainer, we're going to unpack exactly how we transitioned from traditional machine learning to this entirely new discipline of AI engineering, and, more importantly, what it actually takes to build real-world applications with these powerhouse foundation models.
So here's our structural roadmap for today to help you understand both the why and the how of this new landscape. We'll hit 1. The AI application explosion. 2. Rise of foundation models. 3. ML versus AI engineering. 4. Real-world AI use cases. And finally, 5. The AI engineering stack.
All right, Section 1, the AI application explosion. To really frame this, let's look at this quote from the author. You know, the AI community has actually known since the landmark 2012 AlexNet paper that simply scaling up a model, using faster GPUs, throwing bigger datasets at it, makes it better. So, the fact that ChatGPT was highly capable wasn't actually a shock to experts. The real shock, the explosion of new possibilities it unlocked. A seemingly small bump in model quality metrics didn't just give us a few extra apps, it completely shattered the barrier to entry. Suddenly, developers could build these highly capable applications without writing a single line of model training code. Think about what that means for a second. AI transformed overnight from a hyper-specialized academic discipline into this incredibly powerful tool that you can access right now.
And the visual proof of this explosion is just staggering. When you look at the growth of open-source AI engineering tools, things like AutoGPT, LangChain, Ollama, Stable Diffusion, they are growing faster than literally any other software engineering tools. Within just a 2-year window, they've rapidly eclipsed massive tech phenomena, even things like Bitcoin. And honestly, they're on track to blow past the most popular web development frameworks of the last decade, like React and Vue. We've just never seen developer adoption move at this kind of velocity before. So, how did we actually get here?
That brings us to Section 2, Rise of Foundation Models.
We hear the term LLMs, or large language models, all the time, right? But the broader, actually more accurate term is foundation models. Now, it's crucial to realize these didn't just spontaneously appear out of nowhere. They're actually the culmination of research dating all the way back to the 1950s. But what really supercharged them recently is a training technique called self-supervision. This allowed them to scale massively, basically absorbing the entire internet rather than relying on humans hand-labeling spreadsheets for every single data point. The word foundation here is key. It signifies their extreme importance to modern apps and the fact that they serve as a base layer that can be fundamentally adapted for vastly different needs.
This core shift totally shatters the old boundaries. For a long time, AI research was super siloed by data modality. So natural language processing folks only dealt with text, computer vision folks only dealt with images. If you trained a task-specific model for sentiment analysis, it couldn't translate text, it definitely couldn't identify an object in a photo. But foundation models, they demolish those walls. Right out of the box, these general-purpose models can handle sentiment analysis, translation, and even cross-modality tasks, like taking an image and instantly generating text about it. They are insanely versatile right from day one.
Let's move to Section 3, ML versus AI engineering.
Now look at the stark difference in real-world job postings. On one side, you still see companies lumping generative AI under traditional machine learning engineer titles. But on the other, you're seeing the rapid emergence of a completely distinct AI engineer role. In fact, recent survey data noted a 75% average monthly increase in professionals actively adding generative AI skills to their profiles. Basically, a massive new job market has emerged that is focused explicitly on working with these pre-built general-purpose systems.
So let's break down the 3 distinct ways this new discipline actually diverges from traditional ML. First up is focus. Before foundation models, you spent your time training your own models from scratch. AI engineering, though, is all about adapting a model that someone else, usually a massive corporation with a ton of resources, has already trained. Second is infrastructure. Because these models are huge, AI engineers deal heavily with things like inference optimization, latency reduction, and managing giant compute and GPU clusters. But the third difference, well, it's probably the most exciting. Traditional ML meant gathering data and training a model first. The actual product came last. Today, AI engineering is often led by full-stack developers who can build the product first. They test a concept using an off-the-shelf API, get instant user feedback, and then iterate. It is a completely flipped product-first workflow.
Next up, Section 4, Real-World AI Use Cases.
The potential applications right now seem literally endless, which, frankly, can be a bit overwhelming. To organize the chaos, Amazon Web Services neatly categorizes the most impactful enterprise apps into 3 focused buckets. We have customer experience, so think intelligent chatbots and hyper-personalized support. Then there's employee productivity, tools like AI coding assistants or automated meeting summaries. And finally, process optimization, using AI to automate repetitive tasks like lead management, invoicing, or even synthesizing artificial data to train better internal models. If you're looking to build a startup or optimize a business, these 3 areas are exactly where you want to focus your energy.
But the absolute holy grail of these use cases right now is the AI agent. You've definitely heard the buzzword, but an agent is specifically an AI system that can understand a complex task, create a multi-step plan to solve it, and then actually use external tools to execute that plan. For instance, it doesn't just write a restaurant recommendation for you, it actually has permission to open a search engine, find the phone number, make a reservation, and add it to your calendar, hopefully without accidentally booking you a flight to Paris in the process. The level of interest around agents currently borders on total obsession, simply because the economic potential of systems that can autonomously execute complex workflows is just staggering.
And finally, Section 5, the AI engineering stack.
If you want to be an AI engineer, this right here is your playbook. To cut through the incredible amount of hype and FOMO happening right now, we really need to understand the concrete technical stack required to actually build these apps. There are 3 fundamental layers. When you're building an AI application today, you're almost always going to start right at the top, the application development layer. This is where you use prompts and APIs to quickly turn an idea into a working demo. Now, if you find the off-the-shelf model isn't quite accurate enough for your specific business logic, then you move down to the second layer, model development. This is where you tweak things, maybe bring in your own proprietary data or fine-tune the model's behavior. And finally, as your app scales and gets real traffic, you move down to the bottom layer, infrastructure. This is where you ensure the model runs reliably, securely, fast, and most importantly, cheaply on dedicated compute clusters. Starting at the top and moving down, that is the modern AI engineering workflow.
We've seen how the rapid evolution from basic language models to these incredible general-purpose foundation models has birthed an entirely new, fast-paced engineering discipline. We've shifted from training models in total isolation to rapidly adapting them for these amazing product-first workflows. But as we look toward a future dominated by AI agents capable of planning and actually using external tools, I want to leave you with this thought. As AI begins to autonomously navigate complex, real-world tasks, what will actually be the limit of what we can automate? It's a massive question, and it's one that developers and businesses alike will be answering over the next decade. Thanks for joining me on this explainer, and keep learning.